Okay, so to finish up, as promised, a quick review of lasers in agriculture. The really short summary is there's not much use of lasers in agriculture. So, the laser fence is a demonstration, but it has its role in agriculture, particularly in bird deterrence. And potentially, laser fence could find a place further in deterring ground animals. So it would be a good example of using a laser technology in an agricultural setting. But what others may there be? And in agri-tech, I always think it's from farm to the table. Okay. So the simplest things where you might find lasers are just people using things like laser range finders, use of measuring horizontally across fields, or even vertically. Height of grains in stores, height of product in a silo, something like that, given a feed out. And quite a lot of work's been done on looking at sort of canopy heights, how high plants are growing and stuff like that. So they're the sort of simple ones using fairly readily available laser measuring technology. But things can get really quite interesting if you use some of the things which lasers give you. Lasers give you specific wavelengths. Things can be, you can point your laser at something and reflections can tell you things. And I'm not going to actually say that I understand what portable shifted excitation Raman difference spectroscopy is. Juan, do you know what it is? No? So, but you need a laser to do it.
Yeah, the Raman is useful to identify the chemical composition. Not exactly the chemical composition, is to know what is the chemical state of the elements.
Yeah. So
you can carry out knowing big area, micro, and exists a lot of things.
Yeah.
And it's useful and powerful.
Yeah. So basically, the laser allows you to do some really sort of complicated spectroscopy to do it. So people at this institute in Berlin, and before I continue, I've got to apologise, as I've literally downloaded things like this today, so I'm not an expert on it, I'm just chucked some things into a slide and presented it. Have demonstrated they're able to measure the ripeness of apples. It's portable, they can work this system through an orchard, shining these lasers at the apples and determine when they are just the right ripeness to be picked. Is it important? Of course it is. Because if you get one, that allows you to pick the perfect day for harvest. And if you are 1 week out on that, your storage life of your apple can change by up to a month. And things like storage life, I guess, and I think our colleagues from Angel Camacho could have a handle on this. That will, affect the value of your product, how much money you make in return for your product. So there's an example where we are able to potentially use a system to give us informed decisions about harvesting. Another big laser application is something called LiDAR, and I know colleagues like Alex and some of his colleagues from his cohort have used LiDAR, both from drones and other means. It's essentially a sort of light-based radar. Excuse my simplistic description if you understand it more than I would, but it effectively lets you make very detailed sort of topographic measurements. You can shine the laser beam around the room and it'll pick up a bounce off of Dave and it'll work out with something for Dave, but it picks up everything around the room and you can build a 3D topographical image of the room itself. So when we use LiDAR, we can certainly start thinking about getting quite detailed mapping, not necessarily just in 2 dimensions, of the environment. So again, I've picked a whole load of YouTubes, but that's not because I've been sitting there watching them and listening to them. So again, apologies if they don't turn out to be the most wonderful YouTubes. And the question is there any sound on it? Okay. So you can see the robot driving around, and it's got this LiDAR device on it which is flashing a laser beam around, and it's mapping out everything in its range. So from all that data you can start working out a whole load of statistics about your yield in your orchards and other fruit farms. So LiDAR is a very important technique there, and you can picture is a lot of crops which could be benefit. The farmer could benefit from understanding the size of the crop in some detail. One of the problems, of course, people deal with crops, and one of the issues clearly is that we use things like herbicides, weed killers. And when you're growing certain crops, and in the early stages of their life, of course, you sort of have to almost, you see the tractors fitted with the big booms just spraying the whole crop in order to get rid of the weeds in between the crop plants. So people want to be able to identify where the weeds are, not the crop, and then they want to spray the weed and not spray the crop. So here's a system again, using multiple wavelength lasers, different colours. They use a fancy optical system to split the different wavelength beams into multiple beams. They direct those multiple beams onto the surface of a leaf. They look at what comes back, both the specular mirror-like reflection and also the diffuse reflection off of the leaf there, and they can plot some sort of profile of that, check against perhaps a database, and using that data they can then identify what is the crop, what is the weed. And then when their weed sprayer, a killer sprayer, herbicide sprayer is out on target, it should be able to only spray the weed. That reduces obviously the amount of herbicide being applied into the ground itself. But is herbicide necessary? Let's not just get rid of weeds. Well, even if we got weeds, let's get rid of herbicides. So researchers at Leibniz University and Laser Centrum Hanover have been using lasers to kill weeds. And so imagine instead of taking all the spray system out of that tractor and then having a little bit of lasers and a few optics, and as it's rolling along, weed is identified, the sort of centre of a weed, the growth centre is identified, and then there's a short, sharp burst of laser energy to burn out that centre to kill the weed. Okay, that sounds really good. It's all doable, and that's a potential use for the weed, for the laser. Same goes to pesticide. It turns out, and I've only just discovered it now, but in a way, We're not the first laser fence. Thankfully, the people who first thought of something to do with lasers and protecting called it a photonic fence. And this was actually going back to 2010. And I can't tell you much about it, but I was quite interested looking through the history of this. So we're going to start just by looking at this video. And it's from Intellectual Ventures. And this is some sort of spin out from some high flyer from Microsoft, I believe. So you got your mosquito flying in the air. And suddenly its all the wings start to disappear. So maybe not smoking feathers, but smoking mosquitoes falling to the ground. The problem is, of course, how the hell do you sort of sit there and fire a laser beam at a mosquito? It would be quite interesting, of course, and I'm not sure if this video is going to show it all, no. So how might you actually do this? And I'm hoping that possibly the next video might show us a little bit more about that. But notice now, we're in 2015, we're 5 years on.
This insect is a killer. Female mosquitoes of certain species kill more than 1 million people each year by transmitting malaria.
This is our first prototype of the photonic fence.
This device is a weapon in the fight.
We're sending light down the room.
The Vice President for Intellectual Ventures, Jeff Dean, has a great time on this job.
When we first built this, it had a sound of a machine gun on it.
But his mission is serious. The machine gun analogy is appropriate.
As mosquitoes are coming across a field of view, it's able to pick one mosquito out at a time, determine that it's a mosquito, and kill it individually, and do that many, many times a second.
It takes high-tech equipment to do that. Called a photonic fence, it uses a camera, infrared light, and a laser.
We're using computers to be able to tell the difference between what's a good insect and a bad insect, and that's a different way of controlling insects than anyone's ever done before.
And the super slow motion video shows what's happening. Watch the mosquito smoke. Because the system will likely be used off the grid and depend on solar cells and batteries, they want to use just enough energy to get the job done.
We want to minimize how much energy we use per kill.
Mosquitoes literally shot right out of the air.
So what's interesting about mosquitoes is they have properties in how they fly. They have a certain size, a certain speed, and they also flap their wings at a certain frequency.
Intellectual Ventures has now partnered with a Florida company that will produce and distribute it. And while the most important mission is controlling the mosquitoes that spread malaria, it could also be programmed to shoot down agricultural pests that devastate crops.
Winning this war, we're going to need lots of weapons. This is one.
Well, Intellectual Ventures and Florida-based Lighting Science Group still need to figure out just when the photonic fence will become available.
I couldn't get a price from it, it's not in the catalogue yet. Really interesting, because I remember this sort of coming out mostly back in 2010. And my memory was they didn't just know it was a mosquito, they knew it was a female mosquito. So that's really good. And as I said at the end, you know, it's not just about mosquitoes. If you can program it, you know, could you have a system which sits there in your crop, around your crop? You know what your pest insects are. If you had a few of them scattered around your area where your crop's growing, would you take out enough insects to actually effectively protect your crop, and you're not using chemicals? One of the reasons why we're not seeing this technology is almost for the same reason perhaps as I discussed earlier this morning. Some of these lasers, my guess, are not class 3B lasers, they're class 4 lasers. And how are you going to be able to work this system in an open field? And class 4 lasers are serious. One of those pulses might also take out somebody's eye. Okay? So I think there are issues, but in theory, it would strike me, well, the other issue is just simply cost. I would imagine a system like that would most probably cost about $100,000 plus, but I can't be certain. So, and that's one of the reasons why we don't see lasers in agriculture very much. Agriculture is still very much a sort of human presence required. It involves people working. If you start looking for class 4 applications but out in the open, you run into quite serious laser safety issues, and generally lasers don't come that cheap, certainly the lasers of this size. But you don't always need to be throwing them out in the field. This thing caught my eye because this sounds reasonably quite doable, but again, as usual, I'm not aware of anybody doing this. But people were, as I understand the terminology, using forage crop plant materials as feedstock. And these people, Los Alamos rings a bell, have been looking at using lasers to sort of puncture the waxy outer layer of the plant. And that helps then microbes and or enzymes to get inside the plant. And it makes that plant more digestible by the animals eating it. And therefore you have a superior livestock feed with most really benefits to your yield and performance of that feed in terms of your farm. So, but again, on this case, I wouldn't have a clue what the laser is, but this could sort of be done in a fairly industrial setting, in the safety of a factory setting. But while you're on about drilling holes into things, another project which I'm aware of is that this university in Florida have been doing the same thing on citrus leaves, and it's quite a simple sort of CO2 laser system which is readily used for marking things in products, in packaging. And the idea is you drill a load of pores through what is often quite a thick waxy surface of a leaf, and then that allows liquid on the outside to be absorbed more quickly than when the leaf is left unpunctured. And so that could again reduce the amount of agrochemicals, and you'll still have them, but you won't need so much because more of it's actually getting into the plant itself. And I come across this just before we came to Seville last year, and I remember Sven talking to us about a virus which is attacking citrus fruits and how it was about to arrive in Europe. And we was walking through Seville with all these lovely trees with oranges on, and that it could be a major problem. And again, you say, well, could this help? Could this help if you could somehow have a machine which goes along the streets and somehow fires this laser beam in and perforates all these leaves so that when somebody sprays them, it comes in. But again, you are then trying to fire a class 4 laser onto many different leaves in many different places, and the technology most probably becomes unmanageable. But if I remember rightly, these people were looking to take it that step further. But I think it could be quite difficult because deployment will be difficult. Farms is not all about land animals either. So here's a classic application I was aware of stingray. So salmon farming is of course very important. When I was quite young, getting hold of a piece of salmon, which I wasn't that aware of, was very difficult, and now it's just another sort of fish on a shelf in Asda's. One of the problems in salmon farming, as I understand it, of course, is they can be attacked by lice. A little louse crawling on the side of a fish. Stingray is a system which gets rid of them. And hopefully this YouTube will give us an idea. This is one for you, Rose, because my understanding is the way that system works. And originally when I saw it, it almost had salmon individually flowing up a tube. Is it's using vision recognition to spot a lice on the side of a salmon, and then they're zapping it with what appears to be a green laser, enough to kill the louse. And they're actually they're relying on the reflectivity of the fish scales to stop the laser doing any further damage to the fish itself. So they have the ability to at least recognise a louse on a passing salmon. Judging by that video, it's no longer just one salmon travelling up a tube in front of a system, it's actually a whole load of them swimming around. But I know for sure that is marketed and is on the system. So coming to the end, I'd like to also look at this. Something which has come back to me several times from a slightly amusing incident where I used to work to something which has received quite a bit of funding in developing. So if you fancy an orange or something on the way back to the hotel, you might call in your little Tesco Extra or something and go to the fruit cell, you pick up your orange or your apple, and normally there's a little sticker on it, okay? And people decided, well, that's a lot of stickers there, and so could we get rid of the stickers? Could we not just laser mark the product?
Shoppers have to look twice before even noticing.
That looks good, I like that.
Fruits, once weighed down by those frumpy stickers,
They don't always come off that easy.
now sport a sleeker look. It's called the laser label.
This is not a melon anymore, it's a branded melon. It's a melon that has its own mark.
Stefan Merritt says labels are etched onto melons and citrus fruits using a dye that is safe and won't break the skin.
You could even on each of these melons have their own number, its own traceability number.
It's an idea that was born out of an identity crisis of sorts. When a piece of fruit loses its sticker, you can't trace it back to where it was grown.
Merritt says grocers frequently pass off cheap fruit as organic. He says laser labels protect against that and stop shoppers from cheating the system.
Customers were swapping labels between cheap and expensive labels. And that happens more than we think.
Not everyone likes the new look.
I don't think it's a good idea. You don't play around with fruit. You just stick with it, that's it, keep it normal.
European regulators disagree. They're allowing lasered fruit in France, Spain, and Poland, with more countries lining up for this taste of the future. Jonathan Vigliotti, CBS News, London.
So back in about 2014, as it turns out, as a result of an Innovate UK project, Marks and Spencer's, M&S, launches laser labels for oranges. Ditch the fiddly, non-sustainable paper labels, and as you can see, they was going to have these oranges laser marked. Doing so saved, initially anyway, the projection was 7 tonnes of labels. So it doesn't sound much in the big scheme of things, but just for oranges, 7 tonnes worth of those little papers is a lot of labels. The one thing I'm aware of, because we've been working with a local company who's really passionate about this, is all those labels are produced and they're all supplied on a reel of plastic. And you've all most probably seen some point where you've had labels on a sticky reel and you've got a bit of plastic. What do you do with the plastic? You chuck it in the bin. And then it's sooner or later it ends up in the sea. And we all know, of course, how important that is. And if you think of all those labels from all that fruit from all around the world, it becomes a really significant impact on the environment. So we should be pleased to get rid of them. So that project took place in 2014. Subsequently, M&S reported label-free avocados. And I can almost track those dates. I didn't realise that 2019 Marks & Spencer's were going to say extended to potatoes and bananas. So I'm going to show you a sample of their produce. I went round to the Marks & Spencer's to get some of these to show you. There you go. Oh, sorry. Whenever I've been to Marks & Spencer's looking for this, they've all still got little sticky labels on. So I wonder why that is. I mean, there's certain issues. I mean, why not laser mark apples? The difference is we bite the apple. So it was sort of deemed that that's not appropriate, where we peel the orange. So the skin is like, we can chuck that away, it does not affect it. But it's sort of quite interesting, because laser marking can be done. It can't be done necessarily in the field. And you most really wouldn't want to laser mark every olive, thinking about, you know, when you've declared it pesticide free, getting it marked, tracking where it goes. But it's not totally impossible. Laser marking of foods is not simple and is very rarely done. I'm aware, or feel I've been aware for some time, that in Italy, people started laser marking Parma hand to stop it being counterfeited. Never actually really found any real things. So it's sort of doable, but there's always that risk, you know, that you somehow damage the food, you reduce its shelf life, etc. But what Marks & Spencer's have done is mostly proved that laser marking of oranges and the like doesn't damage the shelf life. But it looks like maybe it doesn't sell that many fruit either. So that's it. That's all I wanted to say. Is there any questions on that? But as I say, I think the main problem is generally those sort of lasers are quite complex, quite expensive. So actually to make them viable as a benefit to agriculture, then there's got to be changes. There can't be changes to safety, because safety is safety. That makes it sometimes difficult to implement. There could possibly be some cost reductions if a application was to take off, because people are selling more of that equipment. But lasers of any power tend to start quite expensive. So I'm always interested if anybody thinks they've got a laser application. If it's something like laser marking, you can always send me something and we can have a little wander down the lab and stick it under the laser and see what happens. But for now, I think laser fence remains the most agricultural application I've ever had to consider. So.